Dear friends, in today's lecture, I'll discuss answers of some questions given in my previous lectures. I had given you some questions to do as homework. I hope all of you have already done those homeworks. But here only I'll discuss the answers to check whether you have done correct or wrong. Let's see. First question. 1 coulomb is equal to 3 into 10 to the power 9 stat coulomb. This was the first question. Second, 1 coulomb is dash half coulomb. It's 1 by 10 or 0.1 half coulomb. This is the conversion of unit of charge from SI to CGS. Third question I asked, what is the largest unit of charge? Like other quantity, charge has also largest and smallest unit. Largest unit of charge is Faraday. Faraday. This is the largest unit of charge. 1 Faraday. And 1 Faraday equal to 96,500 coulomb. 96,500 coulomb. Also I can give another information. This is equal to charge of 1 mole of electron. This is charge of 1 mole of electron. By using the formula Q is equal to plus or minus Ne, if you calculate, in place of N you will put 1 mole, in place of E you will put charge of electron, you will get a 96,500 coulomb approximately. So 1 Farad equal to 96,500 coulomb, that is the charge of 1 mole of electron. This is the largest unit of charge. But remember one thing, it's a Faraday, not Farad. Not Farad. It is Faraday, because Farad is the unit of some other quantity which we'll discuss later. We will see the difference between Farad and Faraday. Faraday is the unit of charge, but Farad is the unit of capacitance, which will be discussed later at the end of the second chapter. Smallest unit of charge. Smallest unit of charge is, smallest unit of charge, Franklin. Franklin is smallest unit of charge. I hope already you have also written this answer. So Franklin is equal to, how much you have done? Now check, 1 ESU of charge. This is 1 Franklin. This is the smallest unit of charge, Franklin. Then we'll come to the question number 5. Why charge is not fundamental? Let's come to question number 5. Why charge is not fundamental? My question was like this. While writing the formula of current, we are taking the help of charge. By the help of charge, we are writing the formula of current. But here, charge is not fundamental, but current is fundamental. Why? This was my question. So the answer is, charge cannot be measured easily, but directly. Charge cannot be measured directly, but current can be measured easily. Current can be measured by a device called ammeter. After that you will calculate the charge, but you cannot, there is no such device to measure charge in a body, net charge in a body. So its answer is, you can write the answer, charge cannot be measured directly, but current can be measured easily. Then come to question number 6. It's a very important question. Question number 6. Question number 6 is, what is quark? I have told you, you may not find this in your books, but you'll find in the internet. I have told you to see what is quark. I hope all of you have seen. But still I am now giving the answer. What is quark? Quark are the particles. They present inside, but they are the constituent of some other particles. Quarks. Some other particles means protons, neutrons, etc. There are many more particles which are consists of quarks. Quarks are the constituents of those particles. So what are the different type of quarks? Different type of quarks types I am writing here. You see, there are 6 types of quarks total. Up quark, down quark, then charm, then strange, then top, then bottom. There are total 6 type of quarks are there. Also they have the anti-quarks, but we will not go to the anti-quarks. And now we will keep our limit up to quark. They have the symbols U, D, C, S, T, B. These are the symbols denoted for these quarks. And the important thing is the quarks have the charge which is fractional multiple of charge of electron. You see here, up quark has the charge plus 2 by 3e. Down quark has charge minus 1 by 3e. Like this continue. Plus 2 by 3e minus 1 by 3e plus 2 by 3e minus 1 by 3e. So these are the fractional multiple of electron charge. If it is a fractional multiple of electron charge, now the question, now you will put question on my sentence and what I had given in the previous lectures, that electron is a fundamental charge. Now you are putting question on that. How sir you have told electron is a fundamental charge? Also I had told you that minimum possible charge is plus or minus 1.6 into 10 power minus 19 coulomb. Now you are putting question on those 2 sentences. So what are the answer of this? But I will tell you that's right. Still electron is fundamental charge. Still minimum possible charge is plus or minus E. This is not this is. But quarks have fractional multiple of electronic charge. But still how the minimum possible charge is plus or minus 1.6 10 power minus 19 coulomb plus or minus E. I have told you to see the answer. So here I am telling you the answer. So because quarks do not have pre-existence, so minimum possible charge is plus or minus. Quarks cannot exist freely. You will only find the quarks inside the particles, inside some particles like proton and neutron. Inside them only they exist. But outside proton they cannot exist. But what about electron? Electron exists. If I rub a plastic scale on my hair, some electrons fall on my hair. Some electrons 1, 2, 3, 4, 5, 6 like this. Electrons exist. They can transfer from one body to another body. But quarks do not have pre-existence. They cannot exist in nature freely, independently. You can simply write the answer. Though fractional multiple of electron charge quarks has, but still why electron is fundamental charge and the charge of electron is and the minimum possible charge is plus or minus 1.6 to minus 19 coulomb. The answer is quarks do not have free existence or independent existence. Then we will come to from this based on this you have one NCERT book exercise question number 31. Question number 31. All of you after this video or now also you can open the NCERT book and you can able to see question number 31. First chapter NCERT book exercise question. The proton and a neutron, they consist of 3 quarks each. Proton and a neutron each consists of 3 quarks. Proton consists of 3 quarks, neutron consists of 3 quarks. And only up and down, only up quark and down quarks are there inside proton and neutron. So what is the quark constituent of a proton and a neutron? That is the question number 31. What is the quark constituent of proton and neutron? So maximum 3 quarks are there. That is also restriction is up and down only. So what will be the quark constituent? First better we will do neutron. So the constituent will be like this such that net charge will be 0. And I am again reminding plus 2 by 3e of and down is minus 1 by 3. Then you can use here your brain. So how many up and how many down quarks are there in the neutron? Either 2 up 1 down or 1 up 2 down, but net charge must be 0. If net charge will be 0, then it's obvious the constituent is UDD. This is the quark constituent, it is written like this. UDD. You can check, see here, U plus 2 by 3E and 2 down. So minus 2 into 1 by 3E. But the net charge now 0. So neutron has quark constituent UDD. You can check it here. Here now the net charge must be plus E because this is photon. Must be plus E. UD. This is the quark constituent. You check. 2 into 2 by 3E minus 1 by 3E. This becomes plus E. So this is the question number 31 answer you can be able to do. Now about quark is over. We come to NCERT book. I had given you the homeworks to do, but NCERT book example 1.3 is a little difficult for the students. Let's discuss that one. 1.3 example. NCERT example 1.3. The question is, what is the total positive and negative charge in a cup of water? Cup of water, that question is given, but cup varies from person to person. Some are using very small cup, some are using very big cup, so that will vary from person to person. But how much water is there? But NCERT book has given some 250 gram water like this. But now the question is coming in your brain. If in exam this question will come, how much water you will take? So in exam when this question will come, in question paper it will must give the specific amount of water. Some gram like 30 gram, 36 gram or some gram it will give in the exam. It will not leave like your NCERT book direct question cup of water. It will give this much, find the total positive or negative charge in this much gram of water. For example, let us take 36 gram. I am taking 36 gram. Easy to for divisible. So I am taking 36 gram of water. I am doing the question taking 36 gram of water will be easy to solve. Okay. So, but in NCERT book it will give the in exam the exact amount of water it will give, not will leave the question like cup of water. What about now? You see about water H2O. All of you know. So this H2O. What is the molecular mass? 2 into 1. And 1 oxygen, this oxygen molecular mass 16, total becomes 18 gram. Now we have to use mole concept, chemistry mole concept. 18 gram water contains 1 mole of molecule. 1 mole of molecule. 18 gram water contains 1 mole of molecule. Now 36 gram water contains how much molecule? Obviously 2. How much molecule? Obviously 2 mole of molecule. 2 mole of molecule means, now you see 2 mole of molecule means here how many electrons now it has? 2 mole molecules. 2 into 6.023 10 per 23 6.2 moles. 2 into 6.02 10 per 23. This is molecules. If this is molecule, now convert it into, see, in 1 molecule, how many electrons are there? In hydrogen, this is 2 into 1, and here 8. Total number of electrons are there 10. Total number of electrons 10. Now you multiply into 10. This much number of electrons. Because 1 molecule contains 10 electrons. This is the electrons. Then what is the charge? Now that means this is small n. We have to multiply then the charge of electron. Now you come to the point. What is the charge? Q is equal to, you can use Ne. If you are writing electron charge, then write minus Ne. So minus, this is n value, this is your n. Now this is your n. So put it in 2 into 6.023 10 per 23 into 10 into 1.6 10 per minus 19 coulomb. You will get the answer like this. By multiplying, you will get the answer in coulomb. Or if you want to write in Faraday, you see, this is the mole, this is the electron charge, If these two are multiplied, it become 1 Faraday. So we can write the answer here also in Faraday. Minus 22 into 10. How much? Minus 20 Faraday. Now it become Faraday. This is the final answer of the book example 1.3. And how much positive charge? You already know, if negative charge is minus 20 Faraday, it is electrically neutral. Positive charge will be also plus 20 Faraday. If you want to write the answer in Coulomb, then we will multiply it. Okay, now we'll go to example number 1.4b. In 1.4b example, this may be your doubt. Generally, some students have that question doubt. That is, question is like this. 1.4. This is exercise 1.4. This is exercise 1.4. Bit A is what is quantization. That already you know. This is a simple definition question. But 1.4b. So this is always the doubt of the students. So this is in macroscopic case. In large case, why we neglect the quantization nature? In macroscopic case, why in macroscopic case we neglect the quantization nature? This is the question. To explain, I am just telling you one simple thing I am telling you here. See, while explaining quantization, I had told you, I had given you the example of an apple, that you buy some apple from market. If the shopkeeper must give you some integral number of apples. The same thing I am telling you. Suppose you are going to buy a rice bag or a sugar bag of around 25 kg or 50 kg. Then when you bring a 25 kg sugar or 25 kg rice bag, if I tell you how many rice is there, how many numbers of rice is there in the bag, or how many number of sugar is there in the bag, will you prefer to count? You will not count. Why? Because the number is so large, you will not count it. If you ask you to count also, then you will just ignore. No, it's not possible to count. There is number is very large. I can't able to count. Why? When the number becomes very large, then we neglect the quantization nature. Just the opposite word of a quantization, we take it continuous. We consider it continuous. We neglect the quantization nature. So, why in large scale? Q is equal to Ne plus or minus Ne. When N is very large, in comparison to the magnitude of charge that is very very large, in that case we neglect the quantization nature. You can write the answer there as N is very large, or when N is very large in comparison to the magnitude of the charge of electron, then the quantization nature is neglected. There is no meaning of a quantization of a charge. It is taken as continuous. Okay, so this is about the example 1.4b, and I'll discuss two more questions from method of charging. I had told you some questions of robbing, charging by robbing. I'll discuss two more questions from method of charging. So first question, now I'll discuss from method of charging. Can a charged body attract an uncharged body? Can a charged body attract an uncharged body? But yes or no? Okay. So now the answer is coming to your body, coming to your mind now. Okay. So is it possible to attract? The answer is yes. A charged body can attract an uncharged body. Practically also this is possible. I had also shown you in one experiment by robbing. When I robbed the plastic skull is totally fully charged. Plastic skull is fully charged. But the piece of paper what I hold, it is uncharged. The plastic skull attract the piece of paper or not? Yes. Plastic skull is charged body, piece of paper is uncharged body, plastic skull attract the piece of paper. How is it possible? When we bring a charged body, suppose this is a charged body, this is a charged body, this is positive charge, this is charged body, near to uncharged body, this is uncharged body. But when you keep very close to it, I have told you, when you keep very close is the keyword of which method of charging? Induction. When it will be very close, the nearer end become negative and further end become positive. It will induce opposite kind of charges in the near end. After that, what will happen? When two opposite kind of charges are there, immediately it gets attracted. So a charged body can attract an uncharged body. Yes. How? The answer you can write by method of induction. Opposite charges develop in the near end of the uncharged body, then it gets attracted. You will write the answer, you can write it in your copy. Yes, a charged body can attract an uncharged body because, or how? When the charged body is kept very close to uncharged body, opposite kind of charges develop in the near end of the uncharged body and it gets attracted. This is simply the answer. Also the practical example I told you. Then we will go to the next question. Can two like charges attract each other? Is it possible? Two like charges generally repel each other, you know, in lower classes. But can two like charges attract each other? Yes, two like charges can attract each other. How they can attract each other? That is only possible if charge of one body is very large compared to the charge of other body. This is one body of charge plus 1000 coulomb. This is one body of charge only plus 1 coulomb. They should repel each other, but when this 1000 coulomb is placed very close to plus 1 coulomb, when it is brought very close to plus 1 coulomb, what will happen here? This plus 1000 coulomb will induce some negative charges in the near end. Induce, this is plus 1 coulomb, but negative charges will induce at the near end and positive charges at the further end. So this 1000 coulomb now will attract this body because negative charges induced here. Its charges magnitude is very large. Some number of negative charges must induce when it is very large to this in comparison to this. Plus 1 coulomb will be neglected at that time. How much charge will induce? In place of that, in front of that, plus 1 coulomb is neglected. Because plus 1000 coulomb will must induce some charge, like suppose I will tell plus may induce here minus 10 coulomb. I told you induced charge is always less than or equal to inducing charge. Less, but it may be minus 50 coulomb. It may be, if it is minus 50 coulomb here, then the repulsion of plus 1 coulomb and 1000 coulomb is neglected. So a charged body, how this question was, can two like charges attract each other? What answer you write here? Yes. Yes, two like charges can attract. But what is the condition? When charge of one body is very large in comparison to other and they are placed very close to each other, then the charged body having large magnitude of charge will induce opposite kind of charges in the body having less magnitude of charge, and then they both get attracted. Okay, so these are the questions I discussed today, and in my next lecture we will start the Coulomb's law. Thank you.